Hey everybody, it's Mr. Dean here. I want to do a quick video over solubility curves, just a review. If you haven't already for this unit, I would advise that you go through the PowerPoints and notes, as well as look at the vocabulary. That's actually on a Quizlet on Google Classroom. All this is on Google Classroom, obviously. Um, but without further ado, let's get started. So this is a solubility curve, also can be thought of as just a line graph. That's pretty obvious, right? This is a line graph. You've got an X and Y axis, and then you've got points plotted, and the lines are connected. Now, what does this mean? First, let's look at what we have on each side of the graph, the labels, and determine what exactly it's telling us. So you have solubility right there on the X axis. This is the grams of a substance that has been added to 100 grams of water. And to use that in solubility terms, this is the grams of a solute that have been added to a solvent and dissolved. Well, potentially dissolved according to the situation. Down here on the x-axis, we have temperature in degrees Celsius. That's just going to increase from 0 to 100, going from left to right. The numbers on the y-axis are in grams, and you can see those as I circle them. They go all the way up to 240. It's important that we pay attention to the numbers and how they're spaced, especially when plotting points. So let's just check out an example of what this curve tells us. I'm going to pick potassium bromide to talk about here. If I wanted to know if potassium bromide is going to fully dissolve in water, this curve is going to tell me that. It's also going to tell me if it's not going to fully dissolve in water, or if it's going to fully dissolve in water with excess. Now, there's vocabulary terms we use for these three situations. The first one is unsaturated. This means that it did not fully dissolve in water. That you could still add more, and and the more that you add would still dissolve. There is saturated, and that is what's going to be represented by the pink line here. Okay, this pink line says that within these conditions, for instance, here, or any of these plots, that potassium bromide is at max capacity for the solvent that it's in this case 100 grams of water. If you put more, it becomes supersaturated. If you put less, it's unsaturated. Now, what is supersaturated? Supersaturated is where you add more solute, in this case we're talking about potassium bromide, to that 100 grams of water, the solvent, and the solvent cannot hold this much potassium bromide, so you become supersaturated. You end up with potassium bromide actually settling at the bottom, floating around in the water, not being dissolved. So, for instance, if I said, what if I add 40 grams of potassium bromide to 100 grams of water at 50 degrees Celsius? Well, I'd go to 40 grams here. I'd go over. I see 50 degrees Celsius. My point's going to be right there. And you see I've drawn it in orange. What does this mean about potassium bromide being dissolved in water? Well, we're under the saturation line. Once again, this is the saturation line. We're under that. So this means we're unsaturated. There's still more potassium bromide that can be added. Now, what if I said, all right, what happens if I add 80 grams of potassium bromide at a temperature of 60 degrees Celsius? Well, that's going to land us right here. Put my orange dot. And what does that mean about potassium bromide in 100 grams of water? At this amount, at this temperature, it tells us in those conditions, it's going to be saturated. Let's do one more example. What if I added 100 grams of potassium bromide at the same temperature we just did, 60 degrees Celsius? So 100 is going to land, and this is important to pay attention to, 100 is going to land right between 80 and 120. It splits the difference there. So, whoops, let me go back. Right there, 60 degrees Celsius, put my orange dot here, and my plot ends up right there. What does that mean about potassium bromide in water? It means in those conditions with that amount of potassium bromide at that temperature, we will be supersaturated. Potassium bromide is going to start to settle at the bottom of our container that we're mixing all of this in. That is a quick review of solubility curves. If you have questions, let me know. But happy studying and good luck. Thanks for taking the time to listen.